Hello everyone! This video series will be all about how to assemble the DADSON Prusa i3.
Hey, pop the trunk, open up, I sold my soul a good price, out of sight, my whole got talent.
Hey guys, this next step will be the last step building stuff on the DADSON Prusa i3 3D printer. In this video we will be doing 4 things. 1. Mounting the heated bed. 2. Mounting the box for the Bigtreetech SKR version 1.3. 3. Showing how to mount the 2 different options of power supply, the ATX power supply and the switched LED power supply. 4. Going over some wire connections and also making the voltage divider we need to make the 12 volt signal from the inductive sensor go down to about the 5 volt the board can handle on its inputs. When we have these things mounted, we are ready to connect wires, which I will leave up to you to do. You can find everything you need to know if you visit the GitHub page for the Bigtreetech SKR version 1.3 or whatever mainboard you use. And I will of course be linking to this down in the description. Let's jump to the final build step. Okay, we are using a 12 volt power supply, which means that we have the positive on 1 and negative on both 2 and 3. So the way I usually do this is that I use a red wire for the positive and a black wire for the negative. Okay, so let me find my wire cutter. Heat this. Okay guys, the thing about using a soldering iron on a aluminum heated bed is that the heated bed essentially is one big heat sink, which means that as soon as you put something hot on it, it will try to dissipate this heat into the entire build plate, which can make it very difficult to solder wires to it. I use a heat gun to heat up the entire build plate, which makes it so much easier to then solder the wires onto it. So that's just a quick tip before you go dive into this solder wire experience. Let's get back to the build. This little helper. Some pieces of Captain tape. And if you don't know what Captain tape is, I can tell you that it is heat resistant, which of course is a good idea when you build stuff in heated environment. Maybe we can spawn a big fat piece for the rest. So that's the heat bed ready for assembly. What we basically need is for the 12 volt signal going into the sensor to become a 5 volt signal when it comes out. To do this, we simply divide it down with some resistors. I don't know why, but for some reason I've had the best results with the PNP versions of these sensors. That is the positive, negative, positive versions, like it's when you use a transistor or stuff like that. Okay, but building a voltage divider, it's not difficult, and there has been a ton of others to do it before me. But now it's also in this video. So if we have a look at this very nicely drawn picture, you can see what we are trying to do. The 12 volt signal, the 12 volt input goes straight in to power this the sensor, and then a 12 volt signal comes out, and we have to make that a 5 volt. So we will divide it, make a voltage divider with a 10k ohm resistor and a 15k ohm resistor. Here are a few images that shows how I soldered up my voltage divider. On the Marlin version you will find in the GitHub page, I have set up so that the servo pin, that's pin 2, is used for the probe, mainly because it's not in use for anything else, and it doesn't have these annoying hardwired pull-up resistors that the in-stop input has. So be sure, if you use my Marlin version, to hook it up with the servo signal pin on the SKR 1.3 or 1.4. Alright you guys, that concludes this video series. The DADSON Prusa i3 3D printer should be ready to go. Since this video has been quite a way underway, the DADSON Prusa, it's right here, actually did a lot of printing, and it's working very nicely. I did remove the IGUS bearings to replace them with the standard LM8UU bearings. They just slide nicer and there is no wiggle, so I can recommend those. But other than that, I just think you should go ahead and build this little beast and enjoy the process and enjoy learning along the way. If you have any questions or any comments, please put them down in the comments area below. Hit the thumbs up if you like the video, the thumbs down if you think it's a messed up piece of crap. Also, if you want to see my next video, remember to subscribe, and yeah, until next time, happy building. Go build! Go build!